the virtual lab set folder on your PC.
No, we couldn't do it the day I came to your office now.
Oh, we couldn't do it.
Yeah.
But
Giving some error.
But you have the file. You have the file. I mean the file. You have the folder on your PC. Even though you don't have the virtual lab installed, you should have the folder. The analyst folder that you have on your PC. So,
The analyst.
yes, the analyst folder.
Okay.
So inside the analyst folder, you're going to see this folder called analyst code snippet. This particular folder. You can see my screen, right?
Mm-hmm.
Okay, so inside this folder, you see all these R files. So there are TXT files, and there are TXT files anyway. So I will start from this lab, exploring R. So the lab there is working with R. Working with R. So let me see if we can find it here. So this, okay, this is working with files. I'm talking about. Let me see what I can have. Working with R, education analytics. Yeah, this is exploring R. So this particular. If I open this, I see this TSC file. I'll just copy and paste this in my R environment. I'll Control A and Control C. I come here to let's paste it here. Okay. Now let's see from the beginning of the lab. Okay, here's this beginning. Okay, so this is the lab working with R on Windows. So this first one saying printing a text string on R console. So here, if I just put a quote and I write anything I want in a quote and I want it, this is just going to print on my R console. If I want it using Control Enter, as you can see here, getting started with R, just going to print like a string like that. And you can perform arithmetic operations in R, like 1 plus 1 is going to do normal addition in R. It does 2. If I do this, it does the normal multiplication. 5 times 10 gives me 50. Yeah. So this hash symbol is to comment your line of code. So if I should remove this hash symbol, you can see it's now white. It's now white in color. So it's saying this as a line of code, but if you don't want it to see it as a line of code, you have to put the hash symbol so that the comment is structuring as comment. Now this is just going to do 10 divided by 5 is 20, as you can see the R console. And let me run this. So pi is a constant value in R that stands at 27/2. Like the normal pi in mathematics. If I run this, it's approximately 3.142. And I can do sine of pi like using a sine function. And I have this result. Now, using logical values now. All these comparison operators it gives you a Boolean value as a result if the condition is true. They say 29 greater than 5. 29 is actually greater than 5, so it's actually going to return true as a result. So it's going to return a true or false statement. So it's true because 29 is greater than 5. Also, this one is to compare left and right, whether they are the same. You use double equality sign, not single equality. And it turns true if the function is true. So 4 plus 4 is actually the same thing as 8 because 4 plus 4 is 8. So this is going to return true, as you can see here. Now, you can also compare Boolean operators. Boolean values. T in R is the same thing as true. I can type capital T and I can type true in true. It's the same thing. So this is supposed to return true also, as you can see here. Now here I want to assign x to 34. I can use single equality sign or less than and minus sign. If I should want this, 34 is going to be assigned to x. So 34 has been assigned to x. So if I should call x now, 34 is going to be returned as you can see on my screen here. Now here I'm assigning 28 to y. I can also say y equals 28 or use this sign. It's still the same thing. So y has 28 has been assigned to y. So if I should want this statement, it means y for me is 28. And if I should do y is equal, this means 2 times x raised power 2. Now the way it's going to do this is I'm saying y is what 2 times x is power 2. Now I've assigned 28 to be y here. Now if I should run this statement, this is going to override 28. So y will no longer be 28, y will now be whatever this gives me. Now this is going to first of all do x is power 2, then multiply the result by 2. Now my x is 34, so it's going to do 34 raised power 2, then the result value is going to be multiplied by 2. If I should run this now, so let's see what x is. This second line is saying that it's assigning x was big greater than it is, but first of all, let me see what y is after that this has been run. So let me see. Y is 2312 because that we just did 34 is power 2 then times 2. Now if I should say x is equal to this, x is now going to be a string instead of 28 it was before. Is it 28 to 34? X was 34 a year before. But since I've assigned x to be this, x will now remain this, x will no longer be 28. Now here I'm assigning the boolean value false to y. Instead of y to be this value, y is going to be false. If I should print y now, y is now false instead of other value. Now this one is talking about calling functions. We have inbuilt functions in R of which can use. Sum is part of the functions. If I say sum 1, 4, 5, this is going to sum all of these numbers together, and this is supposed to give me 10. If I should run this, you have 10 as a result. Now, if I should run this, this is called the repeat. This is called the repeat function. REP. It's going to repeat this first argument 3 times. That's what it means. This comma 3 means repeat this 3 times. So if I should run this now, you can see it's repeated 3 times. Yes, I can. Yes, I can. Yes, I can. Now we have the square root function. You take the square root of whatever you pass into it.
That repeat function, can you repeat it one on each line instead of the same? Is that something you can put to do line to move to the next line or
instead of
on the same row?
By default it does it like what's it called? It creates it as a vector. So repeats returns the result as a vector. But I don't know whether that can be done. Let me try this. Let me try this. The creator didn't work out.
It didn't work out.
It didn't work out. So it's going to return as a vector instead.
No, it has to be after the 3 if it's going to work out. Have you?
No. It's not going to. It's not going to do like that.
Okay.
It's going to put as a vector. You can't consider that. Okay. Now you have the substring function. The substring function, how does it work? You are trying to get a fraction of text from a particular text. So this is the text you are looking at. I want to get a fraction out of it, like, okay, probably this California now. I need to get just calif, that is the first 5 characters. I can use what we call substring function. Then you're going to have a starting point. Starting point is going to be the next parameter, then the stop is going to be the next parameter. Where do you want to start from and when do you want to stop? So let me allow someone into the classroom. Titi, welcome to the class. You're welcome. So
Thank you.
yeah. So this substring function, this is how it works. Now, since I'm specifying 5, so I'm saying out of this California word, pick a substring from this California word, starting from the 5th position and stop at the 10th position. So it means it's going to start from 1, 2, 3, 4, 5. It's going to start from F, which is again 5th position, then stop at 6, 7, 8, 9, 10. A is in the 10th position. So it's going to print Fornia, Fornia. That is what it's going to do. If I should run this now, you can see it brought out Fornia. So it gets a fraction of text from a particular text provided. I think that is clear.
Yeah.
In SQL, the way this works might be different. In SQL, this way it works. I don't know, some relational database might differ, but I think Oracle and MySQL. If I should put 5 here and I put 10 here, it means that start from 5 and print 10 characters for me, starting from position 5. That's what it's going to do for you. So this phonia that I just printed here, if I was to do it in Oracle, it's going to be 5, 6. That is, start from position 5 and print 6 characters afterwards. All right. So I want to try something. I don't know. Let me put a negative sign. I don't know whether I can do something like this. I've not tried this before. Let me try. Okay. It didn't work. Minus 5 to. Let me try something else. But it didn't work. Okay. So moving forward. All right. So this one helps you to load web pages into the browser in HTML format, and this one helps you to check information about the package. Like this question mark is to help you to get information about something in the help window here. In the form of it's going to search you in web version. It's going to give you the results in web format. But if you use just normal single question mark, it's going to give you the like a documentation of what you're trying to ask for, if there exists one. Okay. Oh, who is this person? So there's this help.search keyword, searches help pages for keyword for anything you're looking for. And I'll talk about the single question mark. So let's say, for example, I say, okay, I want to know about the sum function. I'll just question mark and put sum, and I want this, and see help is going to come out there and give me documentation on what? On the sum function. So our documentation. So if I do double question mark, it gives me a web search of that sum. So, I'm still waiting for it to pop up. It's still running. You can see search results. So it gave me a web result of what I'm looking for. So most of the time, we use this normal single. How is it called? Single question mark. You can use this double question mark is usually if you are looking for help on probably a package. Let me say tidyverse package. Let me run this. You can see tidyverse gives you help on those packages and like that. So you can also use the help function. This is saying get me help on this package called base, and this one is saying get me help on what the sum function. All right, I think I've explained this one too. This gives me help on spline package. This command is to install a package called TeamSack. If I need a package called TeamSack, I can use install the packages, then put the package I need in quotes. If I have multiple packages I want to install, I can, instead of putting this guy, I'll just put, I'll concatenate the list of vectors I want to, the list of packages I want to install. Say A, comma, comma, comma B, comma C, comma D, as many packages as possible, then pass it inside this install.package function, and it's going to install all of them one after the other. All right. Uh, so here I can create multiple objects. So here I created on a single line. Here I created an object A 1 to 10 and B to be A raised power 2. So it's going to run it one after the other. So I'm terminating each statement by a semicolon. So first of all, it creates this, then afterwards it's going to run this. And this is going to be this vector raised power 2 in that regard. So if I should run this now, and I call B and see 1 raised power 2 is 1, 2 raised power 2 is 4, 3 raised power 2 is 9, 4 raised power 2 is 16, up to 10 raised power 2, which is 100. And I can save the object I've created using the save command. This is going to save object A, comma B into this as this file. You save objects in .r data as .r data. So this is going to be saved into my data.r data. So that whenever I want to use this object, and probably you log into your R environment and this object was not saved, since you have saved it into this thing, you just have to load this particular file back to your R environment, then you can now work with this your object again. All right. So get here I'm saying get WD. This one is to get your current working directory. Okay, which directory are you working on? It's going to tell you currently on documents. It means if I want to maybe read anything into the environment, I can just call it. If it's on my document, I can just call the file directly without specifying the path. But if that document I'm trying to read is not in the document folder, it means I have to specify the location of that file before I can read it. Or I can set a new working directory using the set wd command. So set wd. And inside this bracket, I'm going to put the path I want as my new working directory. So I can just copy this command like this now and just say I'll put it here. Then I'll just say, okay, maybe it's not document again. I want it to be under desktop. So I think this one to desktop. Then I run it. Then if I should run it now, it has changed my current working directory. So if I run get WD now, it's going to tell me that it's desktop and no longer document. So let me run it. You can see it's now desktop and no longer document. So that anytime you want to access files, you can actually use it directly from desktop. So if probably you find that trying to work is on desktop, you can just read it directly from desktop without having to specify any path. Now this one is saying that I've created an object called A and B. Let's suppose that I don't want to use this object again. I can use the rm function to remove the object from the R environment. If I should run this, it's going to delete A and B. Now if I come here, because I've not deleted it, I can call A, which is this object. I can call B, which is this object. Now, if I should run this command and say rm a comma b, I've run it now. A and B has been deleted. So if I should call A now, it's going to tell me that it doesn't understand what I'm saying. Object A is not found because I've already moved it. I can also use remove in full, as you can see here. It's going to do the same thing for me. All right. So here, I'm trying to load the object that I've saved. I said you can save your object that you have created into a particular file. Save this guy. Suppose I've saved it and I want to reuse that object. Let me save it. So So let me create this A and B again. I've created it. Then I want to save it. It has been saved. I've changed my working directory to desktop. So it has saved on desktop. I go to desktop now. Let me go to my documents and go to desktop. Desktop. Where is it? You can see it here. My data.outdata. It has been saved to my desktop because my current working directory. Now if I should go back and let me go and remove my AB, my object AB that I've created. So if I should run this now, it has moved A and B. So if I should come here and call A and B now, let me call A. What are you seeing? Object A not found. It means I can no longer access object A. Now, since if that should happen, and since you have saved the object, I can load the object back to my R environment so that I can reuse it. So all you just need to do is to run this command, load my R data, my data.R data, because I've already saved it as this object. So let me try and load this now. Okay, it has been loaded. So if I should call A now, let me call A now. You can see my A is back. So the advantage of saving your object so that you won't lose some things, or you will have to do some things all over again, or probably even lose it entirely. All right, that's it. So this one is just that I'm just saving this object as this command that I just ran here. Doesn't matter. All right. So it means that if I should call TMP as this guy, it means the load function has been already assigned to this. So whenever I call this guy, it means I'm loading what this this data. It means I can now access it. All right. I think now ls function is used to list the objects you have available in your workspace. If I want this guy, these are the objects I have in my workspace. These are the objects I located in my workspace. So I can also use the object command. If I use the object command, it also give me the same result. As you can see here, it gives me the object I've been created in my workspace. This one say a proposed command say returns the object that contain marked substring in their names. So if I should run this guy, it means it's going to return uh, an object that contains the string max, but I don't have max in my object. Let me use UBA. I think I have UBA. Let me use apropos UBA. You can see now it returned up the object that has UBA in my working environment. It just does that for me. Now I'll talk about set WD, how to set working directory. I'll talk about get WD. Example. Now the purpose of example is that probably you want to use a function or you don't know how it really works, and you check the help window and stuff that you still don't understand. You can run the help function to give you an illustration of how you can use the function. So let's say you don't know how to use the repeat function. You can say example and pass the repeat function inside the function. So please let me know if I'm talking very fast. I know I'm actually talking very fast. It's just that I'm trying to cover as many labs that because I have to do like 5 labs. I know it's not possible, but then just let me know if I'm very fast. So let me run this guide. You can see here it gave you different ways you can use the repeat function. So let's see from this place. This is a very long one. So this is where I ran it. So this one say repeat 1 to 4 2 times. So you can say 1 2 3 4 1 2 3 4. So repeat 2 times. Now look at this. It said repeat 1 to 4, each is equal to 2. So instead of 1 2 3 4 1 2 3 4, it does 1 1 2 2 3 3 4 4. So instead of me having to print it 1 2 3 4, then have to go back and print 1 2 3 4 again. It prints it this way. It is not the same as this guy. So I think that is well understood. Do we get it? Do we get this command? Do we get this command? Are we here? Hello? Am I? Am I the only one you need to understand?
Mm. I hear you.
Do you understand this particular command?
Uh,
So this one just
a vector of 1 to 4 each equals to. I really don't understand that expression.
it means print each value from 1 to 4 two times. So print once two times, print two times, print three times, and two times, print four two times. Do you understand that?
Now that 1 colon 4, what is it?
1 colon 4 means 1, 2, 3, 4. It creates a vector 1, 2, 3, 4. So print each of 1, 2, 3, 4 two times. So it first of all start from 1, print it two times, goes to 2, print it two times, goes to 3, print it two times, goes to 4, also print it two times.
Okay.
But this first one is saying print 1 to 4 two times. So it prints 1, 2, 3, 4, then print 1, 2, 3, 4 again. Now, now this one is
Okay.
saying print. I said repeat 1 to 4, then I put a vector 2, 2, 2, 2 like this. It means it's similar to this guy. It means print 1 two times, print 2 two times, print 3 two times, print 4 two times. But look at this. Then it's print 1 two times. Now print 2 once, print 3 two times, print 4 once. So please let's take note of this because they can bring something like this similar to this in your physical certification exam. This one is saying print this each of them two times, but the length should be 4. Now this is similar to this one here, but there's another extra parameter called length. So len is equals to 4. So instead of me to print everything, but when you get to when the vector is up to 4, just stop. So it stops at 1 1 and 2 2. That's why you are having 1 1 and 2 2 here. All right. Okay. I think uh let's see this one. Repeat 1 to 4 each of them two times, times is equals to 3. It means print each of them two times, then do that 3 in 3 places, like 3 times. Okay. Now I think that's it. Uh, so we can okay. So there's another. If you talk about example, then demo also. Demo is going to it's just like example also, but it's it demonstrates how you can use a particular function or anything or a package or something. So instead of this one giving me everything like this example, instead of giving me everything like this, it gives me bit by bit. So for example, I want demo of this rep, you can say okay, first of all shows this first line and tell you to enter so I can see the result. Then it comes to this second one and okay, it gives you something like this. Then tries to enter so I can see the result and like that. So that's how demo works out. So history the history function shows you the last 25 commands by default, but you can specify the number of commands you want to see so far, like the history of commands you have run. But by default, it shows 25. You can specify, say, I just want to see the last 5 commands that I've run. So let me say history of 5. So here you can see it in this history workspace here. The history workspace here. It shows the what's it called? This is going to show the last 5 commands you have run. Where is it? Have I? Is it not showing? which I want it to show. What is it supposed to show? I don't know if it's turning its own result. Okay. Um, this is showing me everything I've done so far. Okay, I think I get it now. So, first of all, it's going to show your history, but the maximum it can show is 25. So, if you check here, is history, like just over my mouse on this history, the max does show is equal to 25. It means the maximum history can show is 25 of them. All right. So you can put uh, the inf command. I think this one is going to show like all everything. It's going to show everything like infinitely. So everything you have done so far. So and also use save history to save your work history, what you've done so far. And maybe if you want to load it, you can use the load history function. Then if you want to create your arc session, you can use the queue function. Edit your arc. Then this data function gives you the list of built-in data sets you have in arc. And let's say Titanic is part of the built-in data set you have in arc. If I want to load the Titanic data, I also say that data into brackets. Then the name of the data I want to call. Titanic is part of the input data set. So let me first run this so you can see data sets. So these are the input data sets. You have BG sales, BG sales.lead, BOD, CO2, cheap rates, D names, video stock market, and the likes. All right, so let me do this. So if I want to do Titanic, I just do this. All right. Here, this one is loading a particular data that is associated to a particular package called mass. So if I want to load this data, I must reference this package. I can do it this way. Or first of all, I load the mass library into my R environment, then I call the cars 93 dataset. By default, if I say data, I don't know that if I say cars 93, you can see that there's no cars 93 by default. So it means I have to, if I want to call it, I have to specify that I'm trying to call this guy that is associated with this package. Or I first of all load the package, then I will now call the dataset. Since the dataset is associated to this package. All right. You have the summary command gives you the 5-number summary of columns, continuous variables, and summarizes the categorical variables by giving you the unique count of each categories in that data set. Let's say, for example, I load this data set called tooth growth. I've loaded it and I want to see it's an individual data set in R, and I want to see the summary of each column. And I run the summary command, and I see this. Length here is a continuous variable, so I can see the 5-number summary, including the mean. This one is a categorical variable, so I can see each category is OJ. We have 30 of this, and we have 30 of this BC. There's no any, there's no value, so you should have seen any if there's a no value. If you see here, this goat has what 60 observations. That's why this categorical variable has 30 and 30, which sum up to 60. Since there's no any. So you can say plot tooth growth, which is going to plot the tooth growth data set using the plot function. Then I've talked about the C function, which creates a vector containing this set of values. And I said vectors can take just a single data type. It's either it's all numeric or all characters. So for example, this is going to be all numeric and this is going to be all characters. You can see on my screen. This is number 12, 39, and 45, and this is ABC. Now, this one I'm trying to say I want to assign 1, 2, 3, 4 to A. If I should run this, going to assign 1, 2, 3, 4 to A. Then if I do this, it's going to call A for me. Now, instead of going to write this, I can actually do this. 1 colon 4. This is going to give me the same result as this. So if I should run this now, you can see 1, 2, 3, 4. As you have seen earlier that time, that we were talking about what is 1 colon 4. So this is 1, 2, 3, 4. All right. Now if I do a plus 5, you know, a is 1, 2, 3, 4. If I do a plus 5, 5 is going to be added to each element in this A. So if I have 5 plus 1, 6, 5 plus 2, 7. I will have 6, 7, 8, and 9. So if I run this, it's 6, 7, 8, and 9 in that order. Also, a minus 10 is going to do the same thing. 8 divided by 5 will do the same thing. We have the exponential function, which takes the exponent of a particular variable. A is 1, 2, 3, 4. So exponent A is going to do exponent 1, exponent 2, exponent 3, exponent 4. So as you can see here, the exponent is as in 2.7 something by default. So let me see, xp. Can I get the value of the xp? So, but it's 2.7 something by default. So then I can take the log of a, which takes the natural log of a by default. If I say log a, you have this answer. It takes the natural log. Now, this one is 0 because the natural log of 1 is actually 0 because the first number in A is 0. But if I want to do it to a particular base, I'll specify a second parameter called base. The base is equal to, so if I want to do the base 10, I'll put 10 here. If I want to do the base 2, I put 2 here. Let's say I want to do the base 2. Now, I have this result. Now, log 1 base 2 is still 0, then you have this one to be 1. Why do you have this one to be 1? Because the second element in A is 2, and log 2 base 2 is 1, because log A base A is actually 1. If the argument of log is the same thing as the base, you have 1 as a result. So if I put this base to be 4, for example, it means the fourth element here is going to be 4, because log 4 base 4 is going to be 1. Let me run this. You can see that the fourth element here is 1. All right. I've talked about sign. A caret 2 means A raised power 2. This multiplication is minimum. And the minimum returns the lowest value between A and B. Let me see. Have I created a variable B? I didn't create it. So let me create a variable B. So if I say mean AB tells you the minimum between A and B. What is A? A is 1, 2, 3, 4. What is B? B is this. So let me say this. So the minimum here is minus 9 between A and B. Look at this A and this B. The first number there is minus 9. The max function returns the maximum, which should be 4, as you can see here. And median returns the die in the middle when sorted in ascending order. If I run this, we have 2.5. And why is it 2.5? Because A is actually 1, 2, 3, 4. And the guy that falls in the middle is actually 3 and 2. So since for me to find the median, I will add these two values and divide by 2. That's 5 divided by 2. That's I have 2.5. And the quantile function returns the 5 number summary, talking about the minimum, maximum, second quartile, first quartile, and the median. And that's VAR returns the variance of the particular vector. If I say VAR 8 returns the variance, and SD returns the standard deviation. Okay. What else? Now here, trying to create a vector that has numbers and string, and I told you earlier that a vector cannot have two kind of data types. It can only be one data type at a time. Since I'm creating this, it's not going to throw up an error, but it's going to force this 22 to a string, because there's no way I can force this guy to be a number. But since I can force this guy to be a string, so since a string is already involved in this vector, 22 is also going to be forced to be a string. So if I should run this now, you can see 22 is now in quotes. So seeing it as a string. So that's why I said earlier, it can't contain numbers and character at the same time. is trying to create a vector of alphabet. So let me run this. Here I'm saying str means give me the structure of this alpha list. It tells you what kind of data type is this guy. So it's just so it tells you the structure of the variable. If I should want this, it tells you what it's a character and it contains six elements and gives you the element that's inside. Let me see this guy. This one it says shows the storage mode of object passed. That's the mode function. So storage mode is the character, and this this is indexing. This is going to return the element in position 1, and that is A. Position 1, this it gave me A, and this is going to return the element in position 2 to 5. That is 2, 3, 4, 5. That will be B, C, D, E, and E. Is that it? B, C, D, and E. Yes, 2 to 5. B, C, D, and E. Here, I'm trying to say that replace the first element with this string. So here, I'm saying element in position 1 should be assigned to what? This guy. So instead of me to have A now, A is going to be replaced with what?
Studio has consistent commands. It has unified interface. It makes easy to navigate and manage through R.
Sorry, who is that? So the first element in this alpha list will be replaced with this string. So if I should run this now, if I should call alpha list, you can see that instead of me to have A here and I have first element. All right, I think that is going to okay. So let me just here. I want to create numbers variable that has a vector of numbers of 1 to 5. So I run this. Now this one is saying that I want to name this what is it called? This vector to have this naming 1, 2, 3, 4, 5. So name these numbers to have this name. So I'm going to give you a name like a column, like an header or something. So 1 is going to be ONE, 2 is going to be TW and all of that. So I should run this now. I already give it a name. So if I call numbers, now I can see it has given the name 1 is 1, 2 is 2, and the like. So I can call them by their name. If I call numbers in code 4, it's going to call this for me. So if I should run this, you can see just return that for me in that order. Now, I think let me talk about this. We have the execute function that creates a sequence of numbers for you. So if I should run this, it's saying that create 40 to a sequence 40 to 47 with increment of 1. So it means starting from 40, then I have 41, then I have 42, 43, up to 47. So if I should run this, you can see 40, 41, 42, up to 47. But this one is saying,
yeah, sorry.
Yeah.
Must the by be there? Can it be 40, 47, and 1?
Okay, I can say comma 1. Yes, I can. So it's going to, but then you have to understand the arrangement of your function. What's the parameter you are trying to specify? So if the by parameter is the guy in the third position of the function, if you put 1 there, then going to use by as 1. But if you don't put the by, you have to be sure that the by parameter is in the third position. So it's going to understand that you are specifying by to be 1. So I can skip this and put this. I'm still going to have the same result as you can see here. Do you understand? And I can decide not to put this 1. By default, it increments by 1. If I should want this, I still have the same result as you can see. But if I want to use anything that is not 1, then I have to specify like this increment by 0.5. So I have 1, 1.5, 2, 2.5, up to 4, as you can see here, 1, 1.5, 2, 2.5. It increments by 0.5. Okay. Plotting vectors in R, I can plot vectors. Here I want to assign a vector to this guy called plot values. Then I want to plot a bar plot using these values. So if I use the bar plot function, I have this result as you can see in my plot window here. I can give it a name if I like. Names is this. This means Sri Lanka is 4, Australia is 5. So that if I run the bar plot again, we're going to have the names here for each bar plot as you can see here. All right, I think okay. Let me run this bar plot 1 to 20. Look at this bar plot of 1 to 20. This is 1, this is 2, and to the last guy here is 20. This one, I'm trying to create a vector that contains a null value. NA in R is seen as what a null value. So we use NA to represent, like you can say not available or not applicable. You can be asked. If I should run this guy, yeah, that's one. Now, is that N is a function that returns a Boolean result if a particular value is null or not. So if I should run insert any on this object that I've created, it's going to tell me if it is null, it's going to return true. If it is not null, it's going to return false. If I should run this and say false, false, true, false, false. The third guy is true because it's an NA. Then if I say sum NA, now if I say sum NA, I'm going to return it's going to return an error because or can return NA if it doesn't return error. It's going to return NA because I can't sum something. If I do 1 to 3, 4, right? If I do 4 plus NA, I don't know NA not available. So 4 plus NA, like NA is unknown. So if I add 4 with something that's unknown, I'm going to end up with an unknown. So it means it's going to return NA. If I run it, you can see I have NA. So if I want to sum the values in this guy, excluding the NA, then I'll put a parameter called NA.rm with true. I can put a single T, I can put I can type true in full in capital letter like this. So if I run this, it's going to sum my A, excluding the NA. So it's going to be 1 plus 3 plus 7 plus 9. And this gave me 20, as you can see here. I can find the mean also and exclude the NA, and the mean is 5. And I can create a new vector that does not have NA. I'll use the NA.omit function to do that. So you can see if I should on this object, you can see my NA is now this guy, excluding the NA value. I say NA.exclude shows the element of the excluding of A. It shows the element of A excluding the NA value. So if I run this shows element of A excluding the NA value. I think that will be all for this session. I think for this particular lab, I think everything here is well understood before we go to the next lab. Any question? I'm looking for some things here. I need save pictures, screenshots. So there are some I think I sent here some practice questions. You can see some. So let me see, for example, there are some things we did here that you can see them in your practice question. For example, I think I talked about one thing like that here. I'm looking for I don't know what I have it here. I'm looking for some questions like that I did try. Okay, let me just forget it. So, uh, what should I do? Okay, I think that's it for this lab. Is there any question for this lab before we move to the next lab? That will be building data sets into R and exporting data from R. If there are no question, I assume that the everything was well understood. So the next time you go to building data sets into R, Let me see. Working with files. I think that'll be the next lab. Working with files. Let me just copy this and paste it to my R environment. So let me do this. Okay. Uh, yeah. What is this? Okay, I'm here. So here we are trying to create a matrix. Now you can see here. If I write this, you and white. Sorry. If I write this, you will not understand what I wrote until probably I want this the function the command for you. Now I'm saying create a matrix with one. It's going to create the matrix with one. The data I'm using to create the vector I'm using to create the matrix is just a single value called one. Then I'm creating it with what? Uh dimension 3, 5. That is the number of records. Oh, sorry, let me use records. The number of rows is 3 and the number of columns is 5. So what is it going to do? It says create a matrix of 3 rows and 5 columns with all values set at 1. Because I'm just creating one, I'm creating a vector of size 15. Because size of a matrix is the number of rows times the number of columns. So I'm creating a matrix of size 15 using just one single value. So it means it's just going to fill the space with just that one single value. So if I should run this now, I'm going to have 15 places with 3 rows and 5 columns. As you can see on my screen here. Now, now A is created as 1 to 15 here. So I'm getting the vector of 1 to 15. So let me run this. Now, I'm now creating matrix using this A with 3 rows and 5 columns using this A. Now, remember, A is now 1, 2, 3 up to 15. So it's 15 values. So it's going to create matrix using that vector. So now by row is actually false. Is it false? Is it false by default? Yeah, I think by row is false. So it's going to create this by column. It's going to create a matrix by column. So what do I mean by that? So let me run this. So you can see now the matrix is being created by column by default. So it starts from 1 to 3. 1, 2, 3 forms the first column. 4, 5, 6 forms the second column. 7, 8, 9 up to what? The 15. But if I wanted to do it on a row level, so that should be 1, 2, 3, 4, 5, first row, 6 to 10, second row, 11 to 15, the last row. So it means I have to specify another parameter called by row. I will say by row is equal to C. At least by row should be true. So create my matrix by row on a row level. So I should want this now. It's now 1, 2, 3, 4, 5, first row, 6 to 10, second row, and 11 to 15, third row. Now, who can tell me what this is going to create for me? Having talked about this one in line 435. Having talked about this, what will this create for me? This command. Hello? Hello, are we still together? What will this command give me if I should run it? Hello, I'm looking like I'm the only one in this class. Mr. Tunde, you are on mute. Can you hear you? I think Mr. Tunde is having issues with his mic. Okay, so this is going to create a matrix, a 5 by 5 matrix, that is 5 rows and 5 columns having 5 as their values. If I should run this, you can see a 5 by 5 matrix having 5 as their value. Now, if I should put something like this, 1 column 5, and this is going to create a 5 by 5 matrix having 1 to 5 as each column, because I'm creating a matrix of size 25, but I'm creating it from a vector of size 5. So it's going to complete my matrix by repeating values over again. So it's going to do 1 to 5 first column. Since my vector is exhausted, it's going to start over again and do 1 to 5, then 1 to 5 until it gets to the last value. So if I should run this now, you can see 1 to 5, 1 to 5, 1 to 5, 1 to 5, 1 to 5. It's really very simple. Naturally, it's supposed to chop an error and tell you that you're creating a matrix from a vector that is not up to the size of the matrix. Or you can say, okay, from a vector that is more than the size of the matrix. If your vector is more than the size of the matrix, it's not going to create, it's not going to use up the whole vector. It's going to stop from where the size of the matrix got to. So, say for example, you have a vector of size 15, but you are creating a matrix of size 12. Let's say 1 to 15 is the vector. It's going to stop at 1 to 12. It's not going to print 13, 14, 15 because the size of that matrix is not enough to contain that vector. All right. So I think, I think that's it. Now look at this now. You're shaping a vector into a matrix. This is a vector 1 to 20. Let me run it. So here, let me call math vector. We have this 1 to 20. Now I'm now saying, okay, I want to now shape this vector to be a matrix. I'm now saying dim this guy, that is, make the dimension of this vector to be 4, 5, that is 4 rows and 5 columns. So let me run this. Now let me now run my math vector again. So you can see it's now in form of what? A matrix. Because I've reshaped it to be a matrix of 4 rows and 5 columns. So it's going to do it by what's it called? By column, because by row is false by default when creating a matrix. All right. If you want to change the class of your vector, you can use the class function and it tells you it's a matrix. Right? You can use the print function to print, the dim function to know the dimension of your vector and see 4, 5. 4, 5. Now, subsetting your matrix, you can use the square bracket. Now, math vector 2, 4 is saying that print elements in row 2 corresponding to column 4. So the guy in row 2, column 4 is what? Row 2, column 4 is 14. Row 2, column 4. So if I should run this should print 14 for me. So as you can see here, 14. Now here, I'm saying print the second row corresponding to all the columns, because I didn't specify anything here after the comma. This, anything to the left of your comma is your row index, and anything after it is your column index. So here I'm saying print the second row, because and just give me for all the columns. So this is going to print this is just going to print the second row for me. So since I'm not specifying it on the column, so I'm print the second row, and the second row is 2, 6, 10, 14, and 18. So let me run this. I say 2, 6, 10, 14, and 18. This is going to print this next one is going to print the third column. If I should run this, it's going to print 9, 10, 11, 12. So let me run this. You can see 9, 10, 11, 12. Now this is going to print the first column up to the third column. So let me run this. You can see the first up to the third column is printed. All right, this one is saying that assign 55 to the element in the first row and what? Third column. The element corresponds to the first row and third column. That is What's the guy there? First row on top column, that's 9. So I'm assigning 9 to be 55. So it's going to change this guy to 55 instead of 9. So if I should want this now, that guy has changed to 55. So if I print my vector now, you can see it is now 55 instead of 9. As you can see here. Uh, okay. Oh. Now this I'm creating a what? A matrix of size 10. Sorry, I said size 10, size 100, 10 rows and 10 columns, having one as all its value has been created. Now here I'm saying that the elements in the fourth row and sixth column are assigned it to be 0. So it will no longer be 1, it's now going to be 0. Let me run this. Okay. Good. So yeah, that's interesting. These things are not in our material. So sometimes you have to do this your lab, go through it and try to see the stuff they did inside so that if you meet them in the exam, you will not be it will come as a shock. So, this one saying is create a contour map of the elevation matrix. First of all, let's see our new elevation matrix because we have assigned 0 to 46. Let's see elevation. See, this is our 10 by 10 matrix. I can see that the guy in the fourth row corresponding to the sixth column is now 0, as you have done here. And let's run this. Let's see what's going to give us. Oh, give us this map, this contour map. For us to see it very well, let me use the Windows function. So probably that will give us an idea. 25,20. So let me run this again. Okay. This is how our results looks like. This is what our results looks like. It creates this for us. It creates a contour map for us. I think where is this starting from? I see. I really didn't get sites. Okay, let's see the 3D perspective of the elevation matrix. So let's do the 3D perspective. So let me run uh this perspective function. Okay, let me go to my. So this is the way it looks in 3D format. Maybe we need to read more about this to understand what so to understand what it really does in real sense, I will have to also need to read about it. Okay, but let's just have an idea of what it does. So this shows an expanded 3D perspective for the elevation matrix. Okay, let's see. This is how it looks like. Okay, okay. I think you should understand how it works now. You should understand how it works now. So this place, this position that is like that's followed is where we have 0. Is where we have 0. So you can say all of this one is balanced. This is the matrix. This is the 3D format of the matrix. So these are all these ones that are not followed are the value ones, and the 0 one is one that's like that is followed in this middle here. So sorry, I think that makes a lot of sense now. Yeah. All right. So that's that. Uh, Here, talking about what create a vector of names. We want this a vector of salary. Now, this is a vector of bonus. Now, I want to create this as a data frame. So I use data.frame, then combine all these vectors into this data frame function. So I have person's name, salary, and bonus created as a data frame. All right, so let me print it. That's good, right? These are good, right? It's form of a data frame. Note that it has to be in form of it has to have the same length, or else you are going to come up with an error. Now this is going to give you the guy in the second column. You can see that's double square bracket. So I have salary like that. Let me try and remove this double square brackets. You can see I have it in form of a data frame. If I put a double square bracket, I have in form of a vector instead of a data frame like this. All right. Now this is going to give you the salary column using the name in the vector, using the vector format. This gives you the same thing as this. This one you're using position, but this one you're using the name of that column. Then also similarly, I can call it like this using the ampersand sign. This is going to give me the same result as you can see. Okay, this one is calling the person's name, and this one is saying call the first column. And this one is going to give you in form of a data frame. Give me this one is saying give me the first record, the first record of the data. So this is the first record of the data. I can see first guy, and here this gives me the head of the data for the first 5 records of the data using the head function. But one is I have the first 5 records. Now the tail function gives you the last 3 records. This is the last 3 records. And I've talked about the summary command before. Okay. Now this is reading what's it called? Reading files into our R environment. We have a read.csv to read CSV files, read.table to read kind of file, like a table formats, any kind of file. It can be a CSV file, it can be a CSV file, it can be what's it called? So and you have the scan function to read text file into your R environment. All right. Now we can do this. These 3 items directly. Specify if I want this. And see it reads this text in that order. By default, the separator is space. That's why I just if I put let me put separator is equal to comma now and read this. You can see it's considering it as a single item. It's considered as a single item because I'm saying that my item is separated by a comma, but there's no comma in this text. So if I want to make it use as 3 items, I have to put a comma to separate it. Say this is then this. Then I run it again. You can see it's read the 3 items accordingly. All right. Here I use the table to read the result data, a CSV file that is a tab separated value file. Now I have to put the separator parameter. But you can use the read.delim function to read a tab separated value by default. So if I'm using read.table, I have to specify the separator. And if it has an header, I will specify the header parameter to be true. Then co-names function is used to get the column names of this table. Then I can use row names to get the row names also. I can use named function to also get the column names. It also works in a similar manner. Okay, as you can see, the names also gives you the column names. Yeah, I'm trying to read the CSV file for population vehicle info. Now, don't forget, this header is also if your uh, if your record has an header and specified header is equals true, this means your data set is going to take the first record as the header. But supposing your data does not have an header, if you put header is equals to true, the first record will be taken as header, whereas it's not supposed to be an header. So if it does not have an header, you have to put header is equals to false, so that I will just give it its own default header. Then you can now rename it in R by yourself. This using the merge function to calculate your data. Here, if you do this, I think that we are talking about the merge function, which is to join data. If you do this, it's going to merge this x and y based on columns that matches these two data frame. But if there is no column that matches both of them, then it's going to do a cross join for you. It's going to do a cross join for you. Now, this is used to get the dimension of the data. The cbind function is used to it's called column bind, to bind a data side by side. Bind the data side by side. Then we have the row bind, to bind in a row wise, that is top bottom, from like append it from the bottom. Row bind. So if I go bind 1 to 4 and 10 and 13, you can see it like this. 1 to 4 is the first row, then 10 to 13 is the second row. But as you use cbind, if I copy this and just say here and put C here, so it's going to do it column wise instead of row. 1 to 4 is your first row and 10 to 13 is your second column rather. I said row. Now, peradventure that the two vectors that are trying to bind are not of the same size, it's still going to bind it for you, but it's just going to come up with a warning that they are not multiple of each other, like they are not the same length. Then what it's just going to do is that it's going to start all over again to complete the binding. So if I do 10 to 12, like this, you can see it's binded the two data sets, but it came up with a warning. So I'm supposed to have 10, 11, 12, and it stops. But since this one is 1 to 4, something has to be here. So it started all over again, complete the binding. So start from 10 again to complete. All right. You have to write your table to export your data from R and to save it. Write your table. So this is going to save this merge data. This code is equals to false. I really don't get what it's doing. But this code dot names equals to false means that I don't want the row index. What do I mean by that? Let's say I call the X data set. Let's say ed. And to the first 10 records of X data set. So look, these are the row names. 1, 2, 3, 4, 5, 6, and like that. So these row names might not need it. I don't really need it. I just need the data. So that's how specify row names because of false. By default, code.names is true. That is, the code name should come with it. But if you don't want it, you can specify it with false, and the header is not going to come with it. Then the separator value and say, okay, if it's separated by tab, we want it this way. And it's worked that way. Okay. Then you give it. Here is you are trying to save it as a particular name. So I'm going to save it as net-data.csv. Put in quotes. File is going to this. Then it's going to export data as this name. So if you go to your your working directory, you're going to find data with this name, med.data or med.data. Then at list docs file says list all the files in the current working directory. So it's going to list all the files in the current working directory. Let's say, for example, my current working directory is desktop. Let me see the desktop. I think these are the files I have here. Let me try and see what's going to pop up. So list those files. This is what I have. Dropbox. This is what I have on desktop. This is what I have on my desktop. All of this is being uploaded to my open directory. Now, this is going to create a data frame of A, B, and C. A is 1 to 3, B is 4 to 6, C is 7 to 9. Note that they are of the same length. So it's going to be created successfully. But if they are of different lengths, it's going to pop up with an error and it's going to be created. So let me run this now. So let me run A. You can see A1 to 3, B4 to 6, C7 to 9. Now, then let me now say C. I want to put C as length 4, 7 to 10. So if I should run this now, you can see error in these arguments imply differing number of rows. 3, 4. This one is of length 4, while others are of length 3, so it cannot combine them together. So that's why you have an error. So it has to be of the same length before you can combine it as a data frame. All right. So co-names of A, to get the column names of A, let's run it. A, B, and C, because these are the column names. As you can see here, A, B, C. Then row names of A, yes, the row names of the data frame. It's just 1, 2, 3. As you can see here, it's 1, 2, and 3. These are the row names. So, all right. So, I think that is all. A plus 1 adds 1 to each element of the data frame. So if I should want this, 1 is being added to all the data columns in the data frame. But this will only work if all of the columns in A are numeric. Because A, B, C here, they are all numeric. That's why A plus 1 can work and add 8 to everything in the data frame. But if a particular column in the data frame is not numeric, then this is not going to work out. All right. Okay. Then we have the order function, which gives you the order of the data vector or what it is. I think I've talked about how order works in. So the T function transposes your data frame. So let's see what A looks like. These are A. If I do T of A, it transposes my data frame. So let's see. So you can see now, my rows are now columns and my columns are rows. So this is my first row. This is now my first column here, 147. My second row is now my second column, while my third row is my third column. I can convert it as a data frame and say, okay, convert the transpose of A as a data frame using the as.data frame function. If I do this, you can see that it's being converted to a data frame, and it gave it a column name by default. Notice the column name of the transpose data. So since I'm going to a data frame, it gives it a name by default. So then I can save the data I'm working with. I can use the save object to save it, save the data, save the object, anything I've prepared. To talk about the save command, and the .r data is used to as an extension to save objects in R. Okay. Then to remove an object, you can use the remove function or the rm function in short. Then probably you want to now load those objects, you can now load using the load function. Okay. Talk about this files. Then dir. How does this work? This performs the same operation as the list.files command. Let's take a look at that. The sort function, it runs. So if you have created a script, so this is a script. This window, everything here is compiled as a script, saved as DASCA practice 1.r. That's a script now is saved as .r extension. So if probably I've written a script and I've saved that first test underscore script.r, and I want to run everything in that script from top to the last thing, I can use the source function I don't need to open the script in R and maybe now one or using this click on sub button to run everything or do Control Shift Enter. I just need to just source the script and specify the name of that script. And it knows you want everything in that script from top to bottom. This question will come out to your segregation exam also. Please take note. So it's a load R commands from the file. It's going to run the script, the line of code in that file and return the result in the console here. All right, I think that is all for this second lab. Do you have any questions so far? I think the last session for module 2 is manipulating and processing data. I think we should be able to do that before today, this class ends. Then I'm going to continue the lab tomorrow. Is there any question before we move to the next lab? Since I've been the only one talking since I'm starting to lose my voice already. Hello, sir. Hello, Titi. Hello, Baba TV. Can you guys hear me?
Hello.
Is there any questions so far, sir?
Okay.
Any question, Titi? Any question?
No questions, bro.
No, I don't have any questions.
Does that mean that everything I've been saying since has been making sense?
You have to go. You have to go and take a second and third look at it.
No, I know. I'm just the way I'm saying is so very fast, but then I just feel like there's still a lot we need to cover. Hello, Titi, can you hear me?
Yes, I can hear you.
How have you been able to cope with my pace?
You said?
Have you been able to cope with my pace?
Me, I'm lost a long time ago.
Please don't be lost.
I wanted to ask, can the exam be rescheduled? Must I write it now? I might need to reschedule it.
If it's still within your window period, you can reschedule it, yes. But then you have to reschedule. It has to be 72 hours before your exam date. Exam time. Like,
okay.
Let's
When
say,
is it supposed to be now?
what did you say? I didn't hear that.
Hello, can you hear me?
Yeah, I can hear you now.
Okay. So when is this exam slated for?
That depends on when you were registered. You can check up the last day you can schedule for your exam. You can check on your DASCA account. When you log to your DASCA account, you go to schedule exam. Then
Okay.
you see a calendar. Then you click on. You keep on going to the next calendar, until you can't go further again. Then you're going to see.
Right.
You're going to see a place whereby you see that you can't click on that date. Probably that date is no longer available. So is that place to be able to know that this is the last day that you are required to have taken your exam?
Okay. All right.
Yeah.
All right. No problem. All right. Thank you.
Yeah, you're welcome. So
Yeah.
let me quickly run through the last lab for module 2. So that is manipulating and processing data. Now, so let me go to the next place. Back. So that will be this guy. So I'm going to copy this now. Copy and so let me go back to my Art Studio. So 1920. So yeah, I'm trying to create a data frame called for text info. The data out of frame function. The first column customer ID is 1 to 6. The second column product is repeat toaster 3 times and repeat radio three times. Okay, so if I should run this, so let me call purchase info so I can see what's inside. That customer ID 1 to 3 to 6. So it means customer ID 1 maybe purchase this product and all that. Now, I have another data from person info created with customer ID 2, 4, and 6, and with states Alabama 2 times and Ohio once. Let me run this. Let's see what's inside purchase info. So we see what's inside purchase info before it is this, and we want to see what's inside person info. It is this. Okay. And now, we want to now merge performing join operations. Now, you can see that this purchase info has customer ID. This person info also has customer ID. Now, I can say, okay, I want to see the product that a particular customer purchased and the state of that customer. So it means I have to merge this table with this table so I can see it using the ID. So they merge this with this using the customer ID. I can use the by. Now I can decide not to specify this by. Why? Because the customer ID for both tables is the same. That's the same naming. So how it's going to understand that I'm going to join using this ID. So is that intelligent to be able to identify that what's it called, related column. So if I want this, it's going to make these two tables the ID. You know, it's 2, 4, and 6 that is common to both tables. So it's joining based on that. So I have the customer ID, you have the product and the corresponding state. So it means customer ID 2 purchase toaster and it's from Alabama. Or probably purchase from Alabama. Or purchase in Alabama, and customer ID 4 purchase radio in Alabama. Customer ID 6 purchase radio in Ohio. Now here, this is going to give me merge purchase info with person info using a customer ID and all that x is equals to true. That is, select everything in this my x, which is purchase info, and join it with person's info. It's going to do a left join. This is a left join because it's x that is at the left. So if I should run this, I have a left join. Everything in the what? In the customer or in the purchase info is being selected, and it's merged using the customer ID with what? With the person info. So you can see customer ID that purchased the product, but the state is not available. But it's only 2, 4, and 6 as what state. Now I can also do a right join, which are going to specify all the right to be true. If I should run this, everything in person info is selected and is now merged with what? It's purchase info. So you can see we have 2, 4, 6. So it's only 2, 4, 6 that's going to be returned because I'm still doing a right join that it's just going to select everything in person info, and everything in person info is customer ID 2, 4, 6. So all this 1, 3, and 5 that is in purchase info is not going to come up because it does not match with what the guy in your right. But then you can do a full join. It's going to do merge, select everything in X and everything in Y, and join it with the related column, which is customer ID. This is going to give you the same thing as your left join here. If I should run it, so you can see here you have this full join. This is a full join. Select everything in X, match it with everything in Y. Then you have what's it called? The left join. You can select everything in X, match it with what matches in Y, and we have a right join, set everything in Y, and join it with what matches in X, which is the guy at the left. Then you have the cross join, which is there's no by. So that's by is not. So you have this cross join. Cross join gives you the total number of records in X times the total number of records in Y. So how many values do I have here? 18. Because I have 6 records in X and I have 3 records in Y. So it's going to have 18 records. So what it's going to do is that everything in X is going to match with each record in Y. You can see 1 to 6 is matched to what? To customer ID 2 in person info, that is the Y data frame. Then 1 to 6 again is matched with customer ID 4. Then 1 to 6 again is matched with customer ID 6. So that's what cross join is going to do for you. All right. Before I proceed, do we understand the concept of joins before I proceed to the next thing? Hello, are we still together? Uh, I think I'm the only one in this classroom. So, okay, this line of code is trying to create a data frame, having subject as the first column. I don't know why I should call this subject because it's names that are here. So let me just call it names. I don't know why I'm calling it. So, name is the keyword in what should I call it? Let me call it F names. F names. Okay, that is maybe first name. Let me just call it F name. Then another column called time, then another column called age, then another column called weight, then another one height. Okay, so if I should run this now, that's created data frame. So let me print it. This is what is inside. First name, time, age, weight, and height. This is going to transpose my data frame. I've talked about that. Here I'm trying to reshape my data. So I'll call it reshape the data. So it's going to reshape employee data varying 3 to 5. Is there any measurement? Okay, with the names, time revised dimension, times names of employees 3 to 5. Okay. So here, I think I'm trying to put my data in long format for the first 3. I think for the first, let me see. Let me see. Let me first of all call my employee data again. So I have this. Let me see what this box out. Let's see what I have here. Now, thing is here. Because it's so we have undo to you can see you have what's it called, age, weight, and height. So I just shape my data having grouping it by age. So if you see it here, I said varying 3 to 5, that is column 3 to column 5. So for column 3 to column 5, create a data frame from each of them. So now you can see, so where's the time again? Time 11, 11, 12, 12, 15. level 11, 12 to 15. Time is constant for every one of them, as you can see here. Now, for dimension, uh, what is it called? Okay, so time dot variable time what's it called? Time var is equals to dimension. So uh, it creates a dimension column having all of this. So age it gives the measurement corresponding to age. So dimension age, the age corresponding to each columns. What's the age here? 34 to 56. So you have 34 to 56. Then second subset weight 80 to 67. Then height also. Then measure ID. This one is just like to give them ID that okay, this one is different from this second category in that in that in that order. So what am I saying? So that is this guy. So this you can see that you create this guy, this varying function to be column 3 to 5, and that's what is corresponding to all of this time variable, uh, which is dimension, which gives it age, weight, and all of that. Then what's the measurement? var dot names is measurement is corresponding to the measurement. Then we have the ID. Then direction is in long format. You can do it in long format or in wide format, as the case may be. But sometimes this might not. This is just like trying to shape the data in long and wide format. But this is more flexible when you are using the reshape 2 package. It's like you can just convert your data in wide or long format. So the reshape 2 package helps you to do this. It makes it more flexible compared to the way it's being done here. I think by the time we proceed in the lab, we should see how reshape 2 package helps us to achieve this than using that reshape function. Uh, let me see. Let me see. Okay, I think this will also be good to know. Now I want to read a particular data frame in this environment, but this is not the directory. It means I have to set my working directory. So first of all, let me get my working directory. Uh, so, let me set working directory. Set working directory. I have to copy this. Then where my data set is not on desktop, so I think it's on downloads slash data set. Let me go and check. I want to go and check. Data sets, downloads, yeah, data sets. Then it's under this additional data set. So I'll just go access my working additional data set. Additional data set. So I'll just run this. If it has changed to that position, so I can run this now. So I'll just remove this. I'll just do the books.csv now. All right. It said no such file or directory. So probably the books.csv is not that directory. So let me check. Additional data set. Okay, it's inside dataset, not additional dataset. So let me change it again and remove this additional dataset. All right. or probably I can just say slash data set. Let me see if I can do this. Okay, let's see. Let me just change it like this. Okay, so my working directory is not data set, so I can just exclude this. And then, okay, it has been read to my R environment. So let me see what is inside. So this is what is inside my boot. I have authorization ID, boot name, authorization, the authorization first name, and authorization last name. Maybe author, I think author ID, boot name, author first name, author last name. This command is going to give me the second and the second to the fourth column. That is boot name to author last name. So if I should run this, you have book name to author last name. This is going to give me the first three records, as you can see here. Now, using the subset function, and this is going to subset books based on author ID that are greater than 110. If I should run this now, you can see author ID here are greater than 110. And that makes sense. Now, what is this going to do for me? This is going to give me all the columns. Okay, it's going to give me this is going to give me the same thing as this guy. This I'm using subset, but this one I'm using like it's more of indexing using logical values, logical operator rather. So I'm saying for books, for author ID in books that are greater than 110, give me all the records. So the columns that sorry, the records that correspond to this condition give me everything inside the books. So if I should run this one, you can say I have the same result. Auto ID that are greater than 110 is being returned. Now here I'm saying okay, subset the books data frame, given that auto ID is in this vector. That's auto ID that are in 1008 up to 1010. So give me the books data frame if you can find their auto ID in this vector. So if I should run this now, as the auto ID from 108 to 110 is being returned. Then this one is also giving me this. It still also give me the same result. Say subset auto ID in 1008 to 1010. I'm using subsets. It's just like similar. So based on this condition, subset auto ID for me. So you can find sorry subset books data frame for me. So you can find their auto ID in 1008 1010. Give me those records. If I should run this, I have the same result as what is here. Sorry, please let me know if I have not confused anybody in this class. Are we together? Are we still on the same page? Okay. So now here I'm saying remove everything in my workspace. Now I said LM, then list is equal to LS. LS is my entire workspace. So it means if I say list is equal to LS and I put the RM function, I put them inside the RM function, please remove everything in my entire workspace. So if I say LS now, first of all, let me say LS. Sorry. Let me say LS. LS. You can see here I have 279 elements in my workspace. I don't want to delete everything in my workspace. I don't want to delete everything in my workspace. Sorry, because I have a lot in my workspace that I'm still using. But if I should run this command, it's just going to delete everything in my workspace. Everything. But I don't want to delete everything. What should I do? I don't want to do that. I really don't want to do everything now. My. Not this one that has my NY in the beginning. Should I just do it there? Okay. All this object that has my. I want to delete every one of them. So I'll just say remove. Let's say my workspace is that has this pattern. Pattern is equal to. I'll put in quotes. I'll put the caret sign. Then I'll put my. Anything that starts with my should be deleted. Let me run this. It has run. I'm now call ls. And remember, my total object is 280. This is 279 object, and this is 280 object. 280th object. Let me know. If I do the ls command now, it means this number should have reduced because I've removed those objects that start with my. So if I should run this, you can say I have 263 now instead of 280. If you check now, everything that starts with my will no longer be there. You can see there is no even m. You can see m, M-O-M-E. There's no my again, except from this capital my. But what I specify is lowercase my. So it's only this my code that started with capital letter my that is still there. So anything that starts with small letter my has been deleted from the workspace. So okay, that's by the way. Also, you can use the cat function to write a word hello on an external text file named firewrite.txt. So I'm going to save this text file using the cat function as a text file. So hello is going to be saved inside this txt file like this. So separator is /n, that is anything it as a new line. So let's say for example I want to say hello. So I want to say hello Damilola. Then I want to add another thing in the new line. I'll say /n. Then let's say hello. There you go. Then I want to write another thing. I'll say /n. I want to let it be in a new line. I'll say hello class. Okay, I'm done. What do I want to save it as? Let me say is hello people. I want to save it as hello people dot txt. It's going to save in my current working directory, but I don't want to save in my current working directory. So what should I say? Let me just save it as my current working directory. So let me save it. So my current working directory is data sets. Don't forget. So if I run this now, it has been saved. So let me check other data sets. Hello people. So, so you can see it here. Hello people.txt. Let me open it. You can see hello Damola, hello Dairo, hello class. You can see it's going to a new line. Hello, after hello Damola, hello Dairo goes to a new line because of that /n that I put, which is and the separator is there. It's trying to say that it's separated with a new line. So anywhere /n is, the next object goes to a new line. So all right. We have file.show, which shows the content of the file write.txt. So if I want to see what is inside this, oh sorry, I changed the name to hello people.txt. So if I want to see what is inside, I can just say file.show hello people. So let me run this. You can see it just automatically shows up what I have inside that file in my notepad this way. Automatically, hello Daniela, hello Dario, and that. All right. Here you say connect to the test write file dot text file. So if I say file con is equal to file, I use the file function to read it. Let me call it LOP. Uh, so this one is like okay. This is just like I want to create what's it called, an empty file. This does not have this does not really have anything in it. I want to create an empty file and save it as this guy. If I should want this, it's going to save as that, so that it's still as this object. Then if I do this, this is going to write this text inside this file. You know, it's called file con and it's saved as this.txt. So I'm saying that save this guy into this file, which is file test write file.txt. If I should do that now, so I'm going to close the connection. I've closed this. Then if I want to see what is inside the file, I'll use file.show again. So you can see hello then world as it is here. Now I said here I'm saying opens the what's it called? Opens the outright file.txt file exclusively for the write operation. So that's what uh the sync function is for you. So if I do cat hello, write the word hello to the outright.file.txt. So what one is this that if I should sync this guy, this file does not exist before. But by the time I run this sync function, it means this anything I do, if I do this cat operation now, it's going to be saved inside this file automatically. So I don't need to come here and say cat instead of cat and specify file is equals to this, blah blah blah, or friend equals to whatever it is. So here in this line, if I should write let's say cat people. From here, file.show hello people, what's inside? Hello Damola, hello Dairo, hello class. If I want to add another thing, I can say hello world and use the append function, which is going to append hello world to what is inside the hello people file before. Let me call it hello people. If I should want this guy now, it's already saved this guy into that hello people file. So if I should want file.show now, you can see hello world has been appended to it. So it's like updates the file using the append parameter. Well, I'm going back to this my sync function. I'll explain what the sync function does. So it opens this file and whatever write operation I do. So as I said, this if I should run this guy, it means this guy is going to be automatically saved inside this particular file by default without having me to specify the file I'm saving it into. Then this one, it says insert a space after the word hello. After I've inserted this guy into this file, it's insert a space that in new line anyway. Then if I do this, I write the word to this, and if I should do this, releases the file being written exclusively. So it means that I want to release the file. I'm not doing any operation with the file again. So first of all, let me run this outright file. It's open for write operations. And let me run this. So hello has been saved inside. I want to add a new line. Then I want to add word now. Or a space. I want to add word now. Then I want to sync the file. So I'm done with what I'm doing. Now let me see what's inside the file. You can see hello word. First of all, hello was added to it. Then a new line. Then word was added. Then I released the file from write operation. And I showed what is inside the file. Just as simple as that. I think, and the last thing here is creating a vector of fruit, vector of actual price, vector of selling price. Then here, I want to bind it together using first of all, still bind the three of them, then convert it as. So I'm dividing fruits, actual price, selling price. Then I want to create another column called profit, which is going to be selling price minus actual price. Then all those binded columns should be converted to a data frame inside output. And if I should want output, I'll see what is inside the result. And here I'm trying to sort output according to the order of the profit. So first of all, I'll see the one of the lowest profit first, then down to the highest profit. But if I do sort foot now, this sorts the individual column foot. Foot is a vector itself here. So it sorts it from alphabetical order, starting from apple, followed by grape, then guava, then orange, then pineapple. Then here we talked about how to create a matrix. Create a matrix 1 to 25, having 5 columns, 5 rows and 5 columns. Then the apply function, this is going to apply to this matrix on a row level. Is going to sort each record. Let me run test matrix. Let me see what is inside. This is the matrix that is inside. 1 to 5, 6 to 10. So let me do this apply function. If I should do this guy, and see on a row level, it's sorting what's it called? The rows. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it sorts the entire matrix on a row level. So instead of 1, 2, 3, 4, 5 now becomes the row because 1 is being applied there. Now, if I say apply on test matrix, on each column, this two is the margin parameter. So on each column, apply the mean. So for each column, the mean of the matrix is being returned. So for the first column, we have the mean to be 3. For the second column, 8. The third, 13. The fourth, 15. The fifth, 23. This is the original matrix. So the mean is 3. The mean here is 8. The mean of this column is 13. And we have the L apply function, which is actually usually applied on a list. And we have the S apply, which returns the result as a vector. So L apply here returns like, okay, on this 1 to 5, give do each element with power 2. If I want this now, so the result return as a list. 1 is power 2, 1, 2 is power 2, 4, 3 is power 2, 9. But S apply, if I do X apply and perform the same operation, return the values is return as a vector format or like this. So 1, 4, 9, 15, 16, and 25 instead of in list format. I think here I'm trying to call the iris data set and I want to see the head of iris. And I want to apply table apply. T apply with table apply. This one means T apply separate length and species apply mean on it. So first of all, let me call data and let me call iris head of iris. So we have separate length, separate width, which are continuous variable, except from species, which are categorical variable. If I say separate length, which is this, and species, T apply on this, and I'm applying the mean function on it. It means for each category in the species column, find the mean of the separate length. So if I should run this now, you can see you have the mean of separate length for each category in the species column. I think that is where I will stop for now. If you can just read about this last part of the what is it called? The graph. But it's not difficult. So here we created the person's names. Let me call it for you. This person's name. This is what's inside. Grimace. If I say company is factor of person's names, it's going to be created as a factor instead of a vector. It's going to be created as a factor. So print company, you can see it isn't created as a factor. So each level is being returned here in ascending order. Children, direct, Grimish. We have like six categories. So I didn't mean you have gender. If it's gender, for example, now it's going to return all the gender, then gives you 2 levels, male and female. So that's how the result is going to be like. So that's the instance of what's it called? Factors. If I say as dot integer company, let's see what's going to happen to this. So you can see here, as dot integer company just gives you an integer value for the position of each person's name in ascending order. So Grimish, which is the first guy in person's name, is supposed to be in 3rd position in ascending order. That's why you have 3 here. Simmons is supposed to be in 6th position. You can see it's the last person. That's why you have 6 here. Now this one is for this Chuan guy. It's supposed to be the first guy in ascending order if we arrange it alphabetical order. So that's why you have this one to be 1. That's the sort of this as the integer of the factor. And levels of companies, it returns the levels that is this guy. So if I should run this guy now, it returns the levels for you, which is this guy. Then you have the plot, which is just the plot of the vector. So I'm plotting salary against bonus, and I want to plot. I want to give. This is going to give you a scatter plot, but my PCH is the point of those points. So I'm not saying PCH is but as dot integer of company. Remember, as dot integer of company is 365421. So you have different plot design for each category. So let me plot this so you can see. It's not the way it's showing this my plot window is not very clear. So let me use the Windows function. Windows we stop now in the next slide. 25,20. Let me plot it again. Okay. So this is what it looks like. You can see. You can see the plot of salary against bonus has different shapes. So this is for I don't know. Okay, let me put the legend so that I can see. So the legend of the chart. Let me add legend. So let's go back to the plot again. So you can see that Truan is the one that has this symbol. Direct is the one that has this symbol, this one. Grimish is the one that has the plus symbol. Ubuntu is the one that has the X symbol. Where is the X symbol? This one here. Sigmoid is the one that has this symbol, and Simmons is the one that has this symbol. I think Truan is the highest of them that has the highest points, plotting the bonus and the salary on the scatter plot. So I think that will be all for this. Yeah, that will be all for this class. I think we have been able to cover up with Module 3 labs and Module 2 labs. So tomorrow we touch the Module 3 labs. I hope we will be finished, but then we still have can go. So if you want to also have an overview of what you have done, so please that you have to go through this recording maybe later after the class. So that will be all for today. I trust we gain 1 or 2 things in this class today. Hello, Titi, are you with me?
I'm with you.
So tell me, why are you sounding like that?